Now here, let's review an idea that you have seen in your previous classes, which is how do we find sides and angles using Sohcahtoa? Sohcahtoa? Well, here's the main idea. When we have a right triangle, and this is pretty important, you cannot think about Sohcahtoa if you don't have a right triangle. You need to have a right triangle in order for you to apply Sohcahtoa. So when we have a right triangle, we can use Sohcahtoa to find the missing sides and angles. Now, what does Sohcahtoa stand for? Let's do a small review here. Sohcahtoa stands for the following. So, which is equal to the sine is equal to the opposite over hypotenuse, which is what we have here. The sine is equal to the opposite over the hypotenuse. Ka, that stands for the cosine equals to the adjacent over the hypotenuse, which is what we have here. And toa stands for the tangent is equal to the opposite over the adjacent, which is what we have here. We can use these three, you can call them formulas. You can use these three formulas in order for you to find angles and sides of a right triangle, which is pretty important. We need to know that this has to be a right triangle. If this is another type of angle, we cannot use Sohcahtoa. So now, let's say this is your angle reference, which is the angle that we're going to be basing our Sohcahtoa from. The side that is real opposite to it, the side that is in front of it, we're going to call that our opposite. The hypotenuse, it's always going to be the larger side. And the adjacent is the side that is remaining here. So again, if we have an angle, the side that is right in front of that angle, that's called the opposite side. The largest angle or the largest side is called the hypotenuse. And the side that is remaining is called our adjacent. So now that we kind of had a small brief, maybe hopefully it's a little fresh in your mind, let's try to apply some problems here. Now, let's try to find x. Notice that here we have a right triangle, so we can use Sohcahtoa. So let's see. What's our reference angle? Your reference angle here is 42. This is a reference angle. Now, in order for you to figure out what of the three sections you're going to be using, are we going to use Soh? Are we going to use Ka? Or are we going to use Toa? We first need to know what do we have and what do we want. So if this is our angle of reference, let's just label our triangle. This means that this is my opposite, which is right in front of our angle. We have our hypotenuse here, which is the larger side, and this means that this is my adjacent. So now look at what we have. We have a right angle of reference, we know the adjacent, and we want the hypotenuse. So if we come here and we look at our triangle, if we have the adjacent and we want the hypotenuse, we know that cat talks about adjacent and hypotenuse. So that means that we're going to be using cosine, because cosine is the only one that talks about adjacent and hypotenuse. So let's set up a triangle. Or let's set up using Sohcahtoa. So we have that the cosine of 42, which is our angle, 42, that is equal to the adjacent. What is our adjacent? 20. Divided our hypotenuse. Hypotenuse is let me rewrite that too. I don't know why it came like that. So it is 42 degrees. 42 degrees. Okay. Once you have this set up, we can apply cross multiply, which is usually what you do here. So we have our setup. We put it over 1, so we can cross multiply. So if we cross multiply this correctly, we have our first cross multiplication. So that means that we can have x times the cosine of 42. That is equal to 1 times 20, which is 20. Remember that we want to have x by itself. So here we need to divide by the cosine of 42, left and right. So we're going to have a cosine of 42. So that means that x is equal to 20 divided by the cosine of 42. How can we find this value? Well, this is where we use our calculator. Make sure that your calculator it's in degree mode, so that will be the first thing that we want to do. You can press mode. Make sure it's in degree mode. So go down, down, one up. Make sure it's in degree mode. So go to degree and we press enter. Now that it's in degree mode, we can quit. And let's put the expression that we want to find the value of 20 divided by cosine of 42. So we're going to have 20. We're going to divide that by the cosine of 42. We press enter. So that means that x is equal to 26.91. Let's just round it to the nearest hundred. So this is how we can find the side using Sohcahtoa. You first look at the setup, then you need to identify what are the three components of Sohcahtoa you'll be using, and then you just basically plug in your info. So let's do another example here. Scroll down. We have the following. Let's try to find x. X, it's right here. So again, this is the angle that we know. So this is the angle of reference. Let's label our triangle. The side that is opposite to it, so that's the opposite. So x will be my opposite. 12, we can see that is the larger side, so that's my hypotenuse. That means that this is my adjacent. So let's see. Let's bring our formulas down here. Now, we want the opposite, x, and we know the hypotenuse, which is 12. So what are the three trigonometric functions, or what are the three parts of Sohcahtoa? Talks about opposite and hypotenuse. So that will be the saw, because we know that in saw, that says that the sine is equal to the opposite over the hypotenuse. So that means that we're going to be using the sine equals to opposite over hypotenuse, because we want the opposite and we want the hypotenuse. So that's pretty much what we have to plug in now. So let's do this quick. So now we're going to have the sine of 21 degrees that is equal to the opposite, and here we see that the opposite is x, divided by the hypotenuse, and we see that the hypotenuse is 12. We have our setup. What do? We cross multiply. So we cross multiply, we're going to have 12 times the sine of 21 degrees is equals to 1 times x, which is just x. So this is pretty straightforward. X is equals to 12 times the sine of 21. So let's see what that is using our calculator here. 12 times the sine of 21. Press enter here. So that means that x has a value of 4.30. Let's keep rounding it to the nearest hundred. Now remember, all we're doing here is identify what do we have and what do we want. Once we know those two things, then we can figure out which of the three components of the Sohcahtoa we can use. Now let's look at a different angle or a different problem here. Now, we don't know the angle in this form. So can we still use Sohcahtoa? Yes, you can use Sohcahtoa to figure out either the angle or the side of a right triangle. So we have a right triangle here. We can use Sohcahtoa. So let's see. This is the angle that we want. So let's see, what do we know? If this is the angle, so that means that the 51 is my opposite. And that means that 55, that's my hypotenuse. That means that this is my adjacent. Now, what do we know here? We know the opposite and we want the hypotenuse. So let's go back here to Sohcahtoa and see what of the three trigonometric functions talk about opposite and hypotenuse. So here we see that in saw, that says that the sine is equal to opposite over hypotenuse. And that's exactly what we have here. We know the opposite, we have the hypotenuse. So that says that we can use sine. So let's set that up. We can have the sine of the angle, which is, we don't know the angle. This is what we're looking for here. That is equal to the opposite, which is 51, divided by the hypotenuse, which is 55. Okay, so now remember from your previous classes that if you want to figure out the angle, you first need to get rid of the sine. One way for you to get rid of the sine is to multiply by the inverse function. So we multiply by the inverse function to both sides. That way it will cancel out. So now we have that theta, or the angle that we're looking for here, is equal to the sine inverse of 51 over 55. Again, we multiply by the sine inverse because if we do that, then the sines will cancel out and we're going to have theta alone, which is exactly what we want, the angle. So how can we figure this out? We can plug in our calculator here. So let's get our calculator. Now we have here theta is equal to the inverse sine of 51 over 55. So sine inverse is right on top of sine, but you first need to press second. So it's right here in yellow, second sine. Sine inverse of 51 over 51. 51 over 55. Extra 5 there. Let's close that out. So now we know that theta, or the angle that we're looking for, is equal to 68.01 degrees. Let's look at our last example here. Now, again, let me bring down Sohcahtoa. So here's our Sohcahtoa. Now, let's figure out what do we have. If this is our angle, this is the angle that we're looking for here. If this is the angle that we're looking for, let's label a triangle. That means that this is my opposite because that's the side opposite to the angle that I'm looking for. So that's the opposite. This is a hypotenuse. And that means that 38 is my adjacent. So let's see. Which of the three functions talks about opposite or adjacent? Because that's what we have. Well, let's see. We see that TOA talks about tangent equals opposite or adjacent, which is exactly what we have. So we will be using tangent equals opposite over adjacent because that's exactly what we have. So let's write that out. So now we have that the tangent of theta, again, theta is what we're looking for here. That is equal to the opposite, but we know that the value of the opposite is 29. And we need to divide that by the adjacent, where the adjacent is 38. We have this. We want to solve for theta, so you gotta remember that we need to multiply by the inverse of the function. So we multiply by the inverse of the function. Because this way, they will cancel out. Boom. So now we have that theta is equal to the inverse of tangent of 29 over 38. Once we have it into this form, get your calculator and plug that in. Inverse of tangent, it's on top of tangent in yellow, so we gotta press second tangent. So now we have that. We gotta plug in what we have inside the parentheses, so that will be 29 over 38. Press enter. So that means that theta is equal to 37.35 degrees. Again, here we try to round our answers to the nearest 100. We have 34.9. We got to round it up because the next number is a 9. So that's 37.35, which is exactly what we have here. Now, here's your entrance ticket. Try to find the missing side. Find the missing side of the following triangle.